Good morning, everyone. A very good morning to all of you. I hope it has been very difficult to wake up early in the morning, and especially during rainy season. I don't know how you people are doing, but there is no other option for us. We have to wake up and we have to take a class. So you must have to attend the class. Yeah, I hope for the yesterday's class, you people have been gone through the PDF that I have been sent to you. I hope you have been gone through that. Yeah. Now let's start our class. Okay. So in yesterday's class, we have been discussed about the type of prismatic channels, means type of channels, and channel boundaries and channel geometry. So yesterday we have been discussed up to trapezoidal section. I hope my voice is audible to you people. Does my voice is audible? I hope my voice is clearly audible to you and yeah. Okay. So now come to the next one. In the case of the circular section, we have been discussed about the trapezoidal sections, right? So you know how to determine the hydraulic depth and how to determine the hydraulic radius. And I have been saying you continuously in the last video, you must have to remember the hydraulic depth and hydraulic radius. See, hydraulic depth is nothing but the average depth of the flow section, where the sections are going to be diverges at the top. Yes. So why I'm saying this is going to be diverges at the top? Why not converges? Now let's see about the circular section. In the case of the circular section, so the people who have attended the environmental engineering, right? So those I'm going to say again the basic, but I am telling you the people who has already attended the environmental engineering. In environmental engineering, part 2 means wastewater engineering, chapter 2 design of sewers. So you are going to design the sewer by assuming the flow as open channel flow. I hope you remember that. And while you are designing, you are going to use a Manning's equation, right? You're going to use the Manning's equation. And by using that circular section, so there are some formulas for by using the Manning's equation. If you remember the Manning's equation, velocity v is equals to 1 by n into r to the power of 2/3 into s to the power of 1 by 2. So what is this Manning's equation? That we'll be discussing in the later. But as of now, you know that in that Manning's, you're going to use the hydraulic radius, right? So now let's come to the discussion of a circular section. Yeah. So now coming to the circular section. Okay. So in the case of the circular section, see, whenever there is a circular section, there is a possibility of a pipe flow, there is a possibility of open channel flow. When do you set as open channel flow? If you allow the flow in the circular section partially. Partially means whether it may be half or more than half or less than half. And when you got it as a pipe flow, when you allow the flow fully into the pipe or circular section, then we are going to call it as a pipe flow. So first let's discuss about the open channel flow. A flow runs partially. So if this is a circular section, now let's take this is the sewer. So I hope you remember that dry weather flow and wet weather flow in the case of the sewers. So let's take this is a circular section and it is allowing a partial flow. It is allowing a partial flow. And now let's take the dia of the circular section as a D and depth of the flow section as a Y. So whatever the dia of the circular section, the dia of the circular section as a D, small d, because I am representing the capital D for hydraulic depth. And whatever the depth of the flow here is Y. So I hope you can observe. I'm taking you a circular section and first one is if we allow the flow runs partially, then what is going to be happen? See, I need to find out all the parameters. Okay. First of all, look, as it is a circle, definitely with respect to center. So this is going to be the center, and from center you can see anything with respect to center, it is going to having a length of whatever. This is nothing but radius, right? Let's take R is the radius of the circular section. So I can write over here D, dia of circular section, and R is equals to D by 2. Okay, now my dear students, what is the total angle made by the circle? 2 pi. Yes or no? What is the total angle made by the circle? 2 pi with respect to center. And now you can observe this portion as whatever this portion is a sector, right? Yes. And this portion is going to be make an angle of 2 theta. 2 theta. So this is theta and this is also going to be theta. Yes or no? So now this sector, see with respect to the center, this is the flow area. This is the flow area. So with respect to center, it is going to be making an angle of 2 theta. Now let's see what is our top width. So let me take out this again. Yes. So now my dear, here this is center. Let's take the center as a O, and this is going to be the radius R, and one side angle is going to be theta. So now what is the top width? What is the top width here, please? This top width, right? Whatever this top width, I want to find out the top width of the flow. See, keep that in your mind. Whatever this blue line represents the water surface, and below that only flow area would be there. Okay. So now, my dear, what is the top width over here? Please tell me. What is the top width? The top width is, see, if this is R, if this is theta, then what about this value? This is going to be R sine theta. Yes or no? So this is theta opposite, right? Sine theta is equals to opposite by hypotenuse. Opposite by hypotenuse. So sine theta is equals to opposite by hypotenuse. What is hypotenuse? R. And this is also going to be R sine theta. But what about this value? This is R cos theta. That is going to be R cos theta. So now you find out the top width, please. What is the top width? The top width is equals to 2R sine theta. Whatever the top width is going to be 2R sine theta. Yes, this question. Yeah. So I hope you can understand that whatever the top width is going to be 2R sine theta. Okay. Now, Yeah. So what about the flow area? And see, once you know the top width, then you can find out the flow area and the wetted perimeter. Come on, my dear. Look, what is the wetted perimeter over here? The wetted perimeter you are looking is, so this is the solid boundary which is in contact with the water. Yes or no? This is the solid boundary which is in contact with the water. So now whatever the length of this solid boundary is nothing but the wetted perimeter. Okay. What is the total angle made by the circle? 2 pi. What is the total angle made by the circle? 2 pi, means 360 degrees. And what is the wetted perimeter for total circle? For total circle, what is the wetted perimeter? 2 pi r. What is the perimeter of a circle? 2 pi r or not? And for angle of 2 pi, the perimeter is going to be 2 pi r. Okay. Now what is the angle made by this sector? What is the angle made by this sector? For angle 2 theta, then 2 theta into r. For total angle of 2 pi, the perimeter is going to be 2 pi r. For angle made by this sector 2 theta, then what is the wetted perimeter? 2 r theta or 2 theta r. So I can write it as 2 r theta. I can write it as 2 r theta. Okay, pi d r. You can write it as 2 pi r. Yes or no? No. So 2 pi 2 r theta. Now coming to the area. What is flow area, sir? Look, the area over here is, now you know this is O. Let's take this is a and somewhere over here B, and this is going to be C. So now whatever the area I require is, flow area is nothing but flow area. See, this is the flow area, right? This is the flow area. So I need to find out that flow area. And in order to find out this flow area, so as this is sector, which means area of sector OABC. But I want this flow area, right? Minus area of triangle OAC. So you have to find out the area of the flow, means whatever the flow area is nothing but ABC, right? So what is the flow area over here? ABC. I need to find out ABC. For finding the ABC, you need to find out area as a out of total sector. You remove the rectangle, sorry, you remove the triangular portion. You remove the triangular portion. So now, come on, my dear. What is the area of sector? So now you know that. You know that. So again, for total 2 pi, what is the area? This is wetted perimeter. What is the total area? Please tell me. What is the total area for 2 pi? For 2 pi, it is going to be like pi r square. For 2 pi, pi r square. Yes or no? So what is the total area of the circle? For total angle of 2 pi, pi r square. But this sector is making an angle of 2 theta, right? So 2 theta. And remember 2 pi, pi r square. 2 theta, theta r square. So what is the area of a sector over here, sir? The area of sector is going to be theta r square or r square theta minus, what is the area of this triangle? What is the area of triangle? OAC. What is the area of this triangle? The area of triangle is going to be half into base 2r sine theta into height. What is height? R cos theta. 2r sine theta into r cos theta. So here, don't cancel down the 2. What I do is, see, let's take this yes, 2 sine theta cos theta. 2 sine theta cos theta means sine 2 theta. 2 sine theta cos theta sine 2 theta, right? So now you take out the r square common, then a is nothing but r square by 2 common, 2 theta minus sine 2 theta. 2 theta minus sine 2 theta. So how I have find out the flow dimensions over here is number 1, top width. What is the top width over here? AC is nothing but the top width. And what about the wetted perimeter? For total circle 2 pi r, for 2 theta, 2 theta r. Similarly, how to determine the area? So once I know the top width, weighted perimeter and area, now I can find out the hydraulic depth and hydraulic radius. Yes or no? So what is the hydraulic depth? Hydraulic depth is nothing but you can simply write down itself here. So you know that hydraulic depth D is equals to A by T and R is equals to A by P. So don't worry about to keeping the values because they are not going to be cancelled down, because you know that see, you can observe here, my dear students, here which is going to be constant? You see top width, weighted perimeter and the cross section area. What is constant over here? R. Radius of the circular section is going to be constant. Yes or no? The radius of the circular section is going to be constant. Now what about the theta? This theta depends upon the flow area. Yes or no? This theta depends upon the flow area. So now, can you please tell me how to find out this theta? How to find out that theta is, you observe here clearly. It is very, very important point. So now you see, whatever this is from the center to here, what is this? This is going to be radius r. Okay. And for the flow area, what is this? This is going to be the depth of flow. Okay. So now, what is the depth of flow? Can I write the depth of flow as, listen to me, can I write the depth of flow y is equals to, what is the total depth from the center to the bottom point r? And what is this vertical ordinate? You see, what is this vertical ordinate? This vertical ordinate is going to be r cos theta. So can I write y is nothing but total r minus r cos theta. Total r minus r cos theta. I can write it as, so whatever this portion of y is known as r minus r cos theta. So if you take r as common, then r into 1 minus cos theta. So if you know the depth of flow, then you can find out the theta value. If you know the depth of flow, then you can find out the theta value. For example, let's say if flow runs as half of radius of circular section. What is the meaning of flow runs as a half of a radius of a circular section? What is mean by flow runs as a half of radius of circular section? So which means what over here, so now my dear, if flow runs as half of radius of the circular section, which means this is y and y is given as r by 2. But you know this is center. Yes. And as you know that is going to be center, and you know that y is equals to r into 1 minus cos theta. Just now I just said that because this coordinate is going to be, see, from here to here, from center to the bottom r, and from center to the top surface r cos theta. Total r minus r cos theta, that is going to be the y value. So now you please substitute over here, r by 2 is equals to r into 1 minus cos theta. R will gets cancelled. When r is going to be gets cancelled, then 1 minus cos theta is equals to 1 by 2. Then cos theta is going to be 1 by 2. So what is the value of cos theta 1 by 2, please? When do you say cos theta 1 by 2? When cos theta is equals to 60 degrees. Yes or no? sorry, when theta is equals to 60 degrees. So now, my dear, what is this value? This theta is equals to 60 degrees. On one side, 60, on the other side 60, then what is the total angle over here? 120 degrees. Once I know the theta, can't you find out the top width? Yes, 2r sine 60. Can't you find out the weighted perimeter? 2r 60 into pi by 180. Can't you find out the area? See, this theta here, it should be in radians, my dear. Whenever the angle is going to be in a free way, it means without any sine or cos or tan, then you have to take it as a radians. I hope you understood. So this is means I'm just giving the example how to find out the theta. How to find out the theta? Once you know the depth of flow, then what is y value? Y is nothing but r into 1 minus cos theta. Okay. Yeah. Okay. So now, second one is flow runs partially. Now, flow runs half. If you say the flow is going to be running half exactly, yeah. So now, my dear, if I say the flow is going to be run exactly half, if I say flow is going to be run exactly half, then you tell me what is this y value? This y value is nothing but r. And what is the top width, please? What is the top width? See, remember, flow runs half means that's going to be semicircle, right? Simply semicircle. No? So what is the top width over here? Please tell me. The top width is, see, that is nothing but the dia of the circular section. The top width is going to be 2r. Or in other words, you can say, what is a flow runs half a semicircle? What is the angle made by semicircle? 180 degrees. Total circle 360 degrees. Semicircle is going to be 180 degrees. So 2 theta is going to be 180. Then what is theta? 90 degrees, right? What is that theta? Theta is equals to 90 degrees. And if you substitute 90, sine 90 is equals to 1. Or simply, as you know, flow runs half r. Then you can see the top width is going to be 2r. And what about the weighted perimeter, please? Total circle 2 pi r. Total circle 2 pi r. And for the semicircle, pi r. Total circle 2 pi r. For the semicircle, pi r. What about area? For total circle, pi r square. Pi r square. For semicircle, pi r square by 2. So you are going to take the weighted perimeter as a 2 pi r for total circle. For semicircle is going to be pi r. Now, please find out the hydraulic depth. Hydraulic depth is nothing but pi r square by 2 into t into 2r. So I can write it as pi r by 4. Or in other words, I can write it as pi d by 8. Can I? Pi d by 8. Because what is r? R is nothing but radius, right? So the radius is going to be half of the hydraulic depth. So I can convert that into depth, half of the dia of the circular section. So I can write the hydraulic depth is equals to pi d by 8. And similarly, you can find out the hydraulic radius. R is equals to a by p. So what is the r value? R is equals to a by p. So what is r value? Pi r square by 2 into what is p value? Pi r. Yes. So now pi will get cancelled, r will get cancelled, then it is going to be r by 2. Or in other words, I can write as r is equals to d by 4. R is equals to d by 4. So when flow runs a half in a circular section, then what is the hydraulic radius? D by 4. The hydraulic radius is going to be d by 4. So I hope you understood what happens when it runs partially. You need to look over these conditions. What is top width, what is weighted perimeter, and what is the cross-sectional or flow area. And if it is going to be runs a half, then what is the conditions? Now, if you understand this, let's go for the next condition. See, when flow runs full. See, if the flow is going to be running full, then simply I can say it as a pipe flow. Simply I can say it as pipe flow. So, in the case of the pipe flow, now yes. So whenever I say it is going to be a pipe flow, now the flow is running fully. When the flow is going to be running fully, then what is the top width? The top width is equals to 0. When the flow is running fully, can you see any top width over here? 0. And as it is going to be runs full, then what is the weighted perimeter? Weighted perimeter is nothing but 2 pi r. What is area? Pi r square, because as it is running fully. Then what is the hydraulic depth? The hydraulic depth means A by T, which is going to be infinity. Why, sir? What is the top width when flow runs full, sir? 0. When top width is 0, the hydraulic depth is going to be infinity. Why? What is the definition of hydraulic depth, please? The definition of hydraulic depth is average depth of the flow section whose sides are diverges at the top. Yes or no? But in the case of the when flow runs a full, then its top is going to be converges or not? And when the top is going to be converges, there is no top width. And when there is no top width, then there is no hydraulic depth. My dear students, here the hydraulic depth will not be applicable in the case of pipe flow. Hydraulic depth can be used only in the case of open channel flow, because in open channels there is a free water surface, and when there is a free water surface there is a top width, whereas in the case of the pipe flow the top width is equals to 0. Now what about the hydraulic radius? Hydraulic radius pi r square by 2 pi r. Again it is going to be r by 2. So what is r value? R value is equals to d by 4. So what is the common conclusion that we can get from over here? Please tell me. What is the common conclusion? Whether the flow runs a half or whether the flow runs a full. Whether the flow runs a half or whether the flow runs a full. Both are going to have a same hydraulic radius. Yes or no? So when flow runs half or when flow runs full, the hydraulic radius remains same. So now let's come to some of the note points. So I can write down some note points over here. Note. In circular sections, whether flow runs full or half, hydraulic radius remain same. Hydraulic radius remain same. So this is the conditions that you have learned already in environmental engineering also. So my point is I want you to look if the flow runs half or full, the hydraulic radius is going to be same. So what happens when hydraulic radius is going to be seen, that we will be discussing later. And you see one more point over here. So what is a Froude number? In the case of the open channel flow, you are going to use the Froude number or not? So that Froude number, Fr is nothing but V by root GL. Yes or no? And now, my dear, V is a function of R. And whereas L is going to be hydraulic depth. L is going to be hydraulic depth. See why I am using the hydraulic radius and hydraulic depth, sir. Why you are discussing all these things? For what purpose you need to find out hydraulic depth and hydraulic radius? Because in order to classify the flow, in pipe flow, I hope you remember, if you want to say whether the flow is a laminar or turbulent or transition, laminar or turbulent or transition, you use Reynolds number, yes or no? And in the case of the open channel flow, in order to classify the flow, we are going to use a Froude's number, and we classify the flows as a subcritical, critical, and supercritical flows. What are the type of flows? Subcritical, critical, and supercritical flows based upon the Froude number. And in the Froude number, the velocity, whatever this velocity is a function of R. Sir, how come you say function of R? Wait for that, I'll tell you later. Velocity is a function of R, where the characteristic length is nothing but hydraulic depth. Yesterday I told you, for analysis, we use average parameters. And are we using a rigid boundary canal or a mobile boundary canal? A rigid boundary canal. What is the degree of freedom? 1 or 4? 1. And what is that degree of freedom? Depth of flow. And are you going to take the maximum depth of flow or minimum depth of flow or average depth of flow? Average depth of flow. And what is average depth of flow? Hydraulic depth. So in order to classify the flow, then you must know the shape of the section. And for the given section, what is the hydraulic radius and what is the hydraulic depth? You please have a look, and now we'll see the classification of flows. So please have a look once. If you have any doubts. Mr. Abhijit Vasu, I have already told you the significance of the hydraulic radius. The significance of hydraulic radius is to determine the head loss. Okay. And now you see this function. To determine the velocity of the flow also you require the hydraulic radius. What is hydraulic depth? So I mean definition. Are Baba, you go to the yesterday's class, I have given that. Let's get back. Class did not stop. So due to power fluctuation, was offline. Was a problem. Power problem came in my home. So that's why. Now let's come to. Okay. So I'll give you one more question. Please observe a question. An example. Please try to solve this example now. There is a semicircular section, and where on the top of it there is a rectangular section, something like this. And now I'm giving you the top width of the flow as 2 meters and total depth of the flow as 2.5 meters. 2.5 meters. Determine hydraulic depth and hydraulic radius. Come on, find out. See, so far I have given you the sections like a rectangle, circle, and all those things. Now I am giving you the combination of those two. So there is a semicircular invert. There is a semicircular invert which is having a sides, which is having a sides. Okay. So I'm giving you a channel. I'm giving you a channel which is having a sides 2 meters apart. A channel which is having a sides 2 meters apart has a semicircular invert at the bottom. So I want to find out the hydraulic depth and hydraulic radius. Please find out. Come on, let's start. I'm giving you 2 minutes of time. Come on, solve it. Okay. Now, see the solution. So first of all, we need to find out the details, right? Yes. Now, I'm going to divide this into, see, this is a semicircular portion, right? This is a semicircular portion. If it is a semicircle, what is the dia of the semicircle? 2 meters. Then what about, this is center. So what about this value? This is going to be 1 meter. Because this is 2 meters, not center 1 meter. Then this value is also going to be how many meters? This is also going to be 1 meter. It's also going to be 1 meter. And what about the remaining value? The remaining value is, this value is going to be 1.5 meters. 1.5 meters. So now, come on, please tell me the details over here. First, what is the top width? The top width is going to be 2 meters. And what is the weighted perimeter, please? The weighted perimeter means, you see, what is the weighted perimeter over here? Come on, tell me. The weighted perimeter here is a side 1.5 and this is going to be 1.5. And what is the perimeter of the semicircle? See the perimeter of the semicircle. Semicircle means pi r. Total perimeter of circle 2 pi r. So I can write this one as 1.5 plus, this is going to be pi into r plus 1.5, which means 3 plus, what is our r value over here? What is r value? R value is equals to 1 meter. So 3 plus pi. What is the 3 plus pi? The value, p value is equals to 6.14 meters. Okay. And then what is the cross section area? The cross section area is equals to whatever the, see what is the cross section area over here? Whatever the rectangular area. See, you can observe there is a rectangle and there is a semicircle. What is the rectangular area over here? 2 into 1.5 plus what is the semicircular area? Circular area is pi r square. Semicircle means pi r square by 2. So 3 plus pi into 1 square by 2. So pi by 2 plus 3, which is going to be 4.57 meters square. Once I know all these values, then I can find out the hydraulic radius and hydraulic depth. So what is the hydraulic depth? 4.57 by top width, which is going to be 2.285 meters. And what is the hydraulic radius? 4.57 by P, 6.14. So which is going to be 0.744. So these are the hydraulic depth and hydraulic radius. No matter whatever the section it is, you can find out the area, top width and weighted perimeter, and you can find out the hydraulic depth and hydraulic radius. Okay. I hope you people got the values. Most of the people has got the same values. Yeah. So that's about the channel geometry. And with this, we have covered the introduction, type of channels, cross sections, and in order to classify the flow, I hope now you may got a overview, because the type of flow depends upon the Froude number I was saying, and that Froude number is a function of whom? The Froude number is a function of whom? Hydraulic radius and hydraulic depth. So as a type of channel section changes, then the hydraulic radius and hydraulic depth are also going to be changes. Then obviously the Froude number is also going to be changes. Okay. So now let's see what is this Froude number. And before going to that, let's see the classification of flow. Let's see the classification of flow. Now, stop your things and start listening. And this is very, very important, and you need to understand much more better. Yeah. So here, what I'm going to discuss is general classification of flow. General classification of the flow. So how you are going to classify a flow? Whenever you take a channel, and in that channel, when you allow the flow, how you are going to classify the flow? So first, generalized classification means with respect to time and with respect to space. With respect to time and with respect to space. Okay. Now, with respect to time and with respect to space, first of all, I am going to discuss whether the flow is going to be steady flow or unsteady flow. Steady flow or unsteady flow. So first of all, I have to say whether the flow is going to be steady flow or unsteady flow. Okay. Sir, when do you say the steady flow or unsteady flow, sir? Now, listen. For this point, I am going to take an example and I'll give you some resources in YouTube so that you can go through the videos. So, but as of now, first of all, let's say, okay, you are going to have a reservoir now. Now plan view. Have a look about this clearly. In the plan view, so this is a flow of water, river. This is a flow of water or a river. So where we are going to construct our hydraulic structure. So this is going to be a weir or a barrage or dam. This is a weir or barrage or dam. I hope you can understand. So whatever, this is nothing but the upstream section and this is going to be the downstream section. I'm showing you the plan view, my dear. I'm showing you the plan view. Okay. So this is a plan view. I hope you can understand over here. Whatever, this is nothing but a weir or dam. So now let's take myself as a weir or a dam. Myself as a weir or dam. So the flow is coming from the upstream to the downstream. In the top view, you can observe. So this is going to be the top view over here. Now, I want to supply water to the field for irrigation purpose. So somewhere over here, there is a field. Somewhere over here, there is a field. Okay. I want to supply the water to the field. Now, if I want to supply the water to the field, I need to supply that water by means of some conveyance. Okay. And that conveyance is nothing but open channel flow. And for that, you require some channels or not. You see, whatever the channels I have given over here. Yes. Yes. You observe this portion. You observe this portion. This is nothing but some opening or not. Yes or no? You can see this is nothing but a canal, and this canal is going to be connected to whom? Crops or field. And this is also a canal which is connected to crops or field. Yes or no? So now, yes, you see, I want to supply water to my field. Now I am going to construct a canal. Whatever. Now this is going to be canal or channel. This is going to be canal or channel. So I am going to supply the water from the source. See, this is nothing but a source of water. Or I can say this one as a reservoir. You know the meaning of reservoir, right? So on a back of a dam or weir, when you store the water, that is nothing but reservoir. So from the reservoir to the field, you are going to supply the water. Are Baba, are you going to supply the water continuously to the field? No. There must be some regulatory gate. There must be some a regulatory gate. So here you can observe there is a regulatory gate, and that gate is nothing but a sluice gate. Sluice gate are control gates. So in order to control the flow, we are going to provide some gates over there, sluice gate. Yes or no? Whenever I require water, I lift the sluice gate and then I allow the water to the field. Don't you agree with me? Yes. So this is a plan view, my dear. This is a plan view. So where whenever I require some water, I am going to open the sluice gate and I am going to regulate the flow or control the flow. In the case of the summer season, I require more water. So I open the sluice gate more and I allow the water to the canal. So if I open the sluice gate, then only water will enter into the canal. Then only it can send to the field or it can supply the water to the community. So now it all depends upon the sluice gate. I hope you understood this plan view. Now what I'm going to do is you please cut down this section. I'm going to cut down the section over here. So and I'm going to show you the longitudinal section. Please have a look. See, this is going to be the plan view. Now if you see the longitudinal section, and in the case of the longitudinal section, especially this portion, please have a look. So whatever I am going to draw, this portion, I am going to draw the longitudinal section, please. So what is this? This is nothing but a canal. This is nothing but a canal. Yes. And whatever here, this dotted line, that's nothing but a sluice gate. What is this, please? This is going to be the sluice gate. Whatever, this is going to be sluice gate. And initially, let's assume the sluice gate is going to be closed, and this is going to be the reservoir, please. Yes. So I am providing you the section view, longitudinal section view of this portion. Now observe carefully. In the case of the reservoir, this is the level of water. Yes or no? In the case of the reservoir, that is the level of water. Now this is a channel, and I can say this is a channel bed. Okay. Now how you are going to state the type of flow, whether it is going to be a steady flow or unsteady flow. I hope if you remember, there are different type of flows like a steady flow, unsteady flow. Yes or no? So when do you say steady flow? When do you say unsteady flow? Think and see. When do you say steady flow? When do you say unsteady flow? Or when do you say uniform flow and when do you say non-uniform flow? Come on. Weir means what, sir? Sir, you are civil engineer or not, sir? Weir means what, sir? Huh? Weir or a dam or a barrage is a hydraulic structure to store the water or to divert the water from upstream to downstream. If you have not heard about that, you have heard now. Now, so see, there are different type of flows, whether the flow is going to be steady flow or unsteady flow. See, whenever there is a flow, you have to define that flow in two dimensions. One is with respect to time and with respect to section. With respect to time, and other one is going to be with respect to section. So now let's see about the section first. Whatever, this is nothing but a section. Okay. Now for suppose if I open the gate. For suppose if I open the gate and see, this is a sluice gate, right? I lift the sluice gate and I keep it quiet. I keep it quiet means I lift the gate and I stop, so that some amount of the water will be goes towards the downstream side or not. So some water will be passes towards the downstream side. Yes or no? Now, yet this particular section, how come you say whether the flow is going to be steady flow or unsteady flow is at a particular section. At a particular section, which means I am keeping the space as a constant at a particular section. Now, let me take at this particular section. So, at the particular section, if the flow parameters remains the same with respect to time. So, if the flow parameters remains the same with respect to time, then we are going to call it as steady flow. Then we are going to call it as a steady flow. So, what is mean by steady flow, sir? At a particular section, if the flow parameters, what is mean by flow parameters, sir? Velocity of the flow, depth of the flow, discharge, velocity, depth and discharge. And you know that in the case of the open channel flow, I'm going to discuss more towards whom? Depth of flow, because whatever the channels I'm going to take, prismatic channels and rigid boundary canals. So the degree of freedom is going to be only one, depth of flow. If the flow parameter remain the same with respect to time, for example, you see, I allow this one, whatever this depth, it has some depth of flow, yes or no? As long as I am going to close the gate or open the gate further, as long as I am going to close the gate or open the gate further, the depth of flow remains same at this particular section, yes or no? Let's say you open the sluice gate today and you just keep it quiet, means you did not change any operation. And today, let's say the water is flowing by around 1 meter, 1 meter. 1 meter of water is going towards the downstream side or canal. And tomorrow also you keep it like that. Day after tomorrow you keep it like that. You did not change. Today same depth, tomorrow same depth, day after tomorrow same depth. At the particular section, today, tomorrow and day after tomorrow, the depth is same, right? At a particular section, if the depth remains same with respect to time, then you are going to call it as a steady flow. Then what do you call? You are going to call it as a steady flow. So my dear students, what is mean by steady flow? Yet this particular section, when I open the gate, some amount of water will flow. And it must be having some velocity. It must be having some depth of flow. As long as I don't operate the sluice gate further, the flow velocity, flow depth remains the same at this particular section with respect to time. Such a flow is known as a steady flow. And what is meant by unsteady flow, sir? So the meaning of unsteady flow is, for example, you lift the gate partially today and tomorrow you want more water. If you want more water, if you lift the gate further, see, if I lift the gate further something like this up to this point, then this much amount of water is going to be there. Yes or no? Earlier, position number 1, this is the one. And tomorrow I lift the gate to here. Then the water level will rise or not? Yes or no? When the water level is going to be rises, more amount of water will travel towards the downstream side. Then the velocity is not same. Yesterday velocity is different, today velocity is different. Yesterday discharge is different, today discharge is going to be different. Yes or no? Why? When I operate the gates suddenly, so then the flow parameters are going to be changes with respect to time. Such a flow is known as a unsteady flow. In simple words, you take at a particular section, if the flow parameters remain same with respect to time, we call it as steady flow. And if the flow parameters are going to be varies, we call it as unsteady flow. Okay. Now, so let's take this as a sluice gate. Okay. And I open the sluice gate and I keep it quiet. As long as I don't operate it further, the flow is going to be a steady flow. Can I say it as a steady flow? Because at this particular section, so this is the water flowing or not? Yes. At the particular section, the flow is going to be steady. I can say. So now, my dear students, can you please tell me when do you say steady flow or when do you say unsteady flow? So, general classification of the flow. Number one, steady flow. Unsteady flow. So, in terms of the definitions, I gave you the definitions differently, but in terms of here, if the flow parameters like velocity with respect to time and the depth with respect to c, what is the meaning of dou v by dou t? What is the meaning of dou v by dou t? At a particular section with respect to time, if the flow parameters remain same, means no change. See, dou v by dou t means variation of the velocity with respect to time is zero. Then we call it as a steady flow. And if dou y by dou t is not is equals to zero, then we call it as an unsteady flow. See, some of the people don't replicate your whatever the perceptions are there. So wait for that. The flow is whatever the open channel flow is not as same as what we see in practically. We see everywhere the flow is going to be normal, but there are a lot of things behind it. You cannot take something constant directly, velocity constant or depth constant directly. So wait for that moment. I'll discuss that. Okay. So now there is going to be the steady flow. I can write down if you want a particular section. If flow parameters means velocity, depth of flow remain same with respect to time, then we are going to call it as a steady flow. And if there are going to be changes, unsteady flow. Now let's come to the example once again. So is it a steady flow or unsteady flow? Steady flow. Is it a steady flow or unsteady flow? Steady flow. See, my dear, at first I am discussing at a particular section. Okay. Now I am going for the with respect to the section. So now I can divide this steady flow or unsteady flow into again two more parts. Uniform flow, non-uniform flow. Similarly, in the case of the unsteady also, uniform flow, non-uniform flow. See, my dear, first of all, I'm discussing whether the flow is going to be steady or unsteady. So when do you say unsteady flow? When sudden operation of gates. In simple words, if you suddenly lift the gate or suddenly close the gate, what happens? Water level will rise or fluctuates. Yes or no? When the water level is going to be fluctuate, then it is going to be create a wave motion, right? Such things are known as unsteady flows. Such things are known as unsteady flows. Or I can give you one more examples. When a ship is passing over a river or a stream, you can see on the sides of the strip some waves are going to be generated or not. Some waves are going to be generated, and that waves are nothing but unsteady waves. Or in other words, I can say flood waves. In the case of the flood waves, you see when the floods are going to be coming, and obviously this is a rainy season, right? When the floods are going to be coming, if there is a continuous rainfall or precipitation is going on, what happens in the water level? The water level is going to be continuously rises or not. When the flow parameter is going to be changes. Today, the depth of water should be different. And in the upcoming 2 days, if the rainfall is going to be too heavy, the level of water in reservoir will rises, or in water it is going to means in rivers it is going to be rises. Today, depth is different. After 2 days, the depth is different. So it is going to be steady flow or unsteady flow? Unsteady flow. Okay. Now, coming to the uniform or non-uniform flow. Once I say steady, if I allow the water, you see, now this point is very clear. On this downstream, see, this is a downstream, right? What is the meaning of downstream? Downward. Upstream means starting. Downstream means the ending of portion. So when the flow is going to be happening, now I allowed the flow to pass into the channel. Now in the downstream side, have I provided any obstruction over here? No. I'm not showing any obstruction. I'm not ending the channel bit. Now you see, if I allow the flow, if the flow is going to be passes like this, which means if the depth of the flow is going to be same everywhere, if the depth of the flow is going to be same everywhere, which means whatever the along the length of the channel, if the depth of the flow is going to be remain same, if the depth of the flow is going to be remain same, then you are going to call it as a uniform flow. Now you tell me, what is meant by uniform flow? If the flow parameters, what is the meaning of flow parameters again? Velocity and depth of flow. If the flow parameters are velocity and depth of flow remain same along the length of the channel, or with respect to space at a particular time, then we call it as a uniform flow. So can you tell me what is a flow, total flow over here for the given condition? For the given condition, it is going to be steady uniform flow. What is that? Steady uniform flow. Why it is steady? Because I am operating the gates gradually. When I operate the gates gradually at a particular section, I am allowing a single discharge and I am allowing a single velocity. So at this particular section, so the flow parameters are going to be constant. So it is going to be steady flow. And along the length of the channel, if the depths are going to be same, so as y1 and y2 same, then the flow is said to be uniform flow. So now my dear, what is mean by uniform flow? The meaning of uniform flow is dou y by dou s is equals to 0. What is the meaning of dou y by dou s? So variation of the depth of flow with respect to space. This is a steady flow. Now this is going to be with respect to whom? With respect to space. If flow parameters remain same, that's going to be uniform flow. And I can write in other words as depths are same, velocities are also going to be same. So along the length of the channel, if the flow depth and velocity remain same, then you are going to call it as uniform flow. I have used this condition in the starting itself. Yes or no? And sir, where do you see this uniform flow condition, sir? So you have to say, where do you see the uniform flow condition? So uniform flow condition can be seen in prismatic channels. can be seen in prismatic channels. With a constant velocity of flow. So what is the meaning of this one, sir? You see, when uniform flow is going to be happen, if the flow velocity remains same, yes. So constant velocity is going to be same. And now it is going to be seen in the prismatic channels only. Okay, fine. What is meant by prismatic channel? Tell me please. Shape, size, slope remain same. If a shape, size, slope remain same, then what is the only variable you can observe? Depth of flow. Yes or no? And now when do you say uniform flow? If a shape, slope and size remain same, and now if the depth is also going to be same, means if the velocity of the flow is going to be same, you know that shape, size, slope are already constant. And if velocity is going to be constant, from continuity principle, if velocity is same, then flow area is also same. Then depths are also going to be same. Literally, I can say shape constant, slope constant, size constant, and depth is also going to be constant. Is there any degree of freedom here? No. That is the reason why uniform flow is ideal flow. Uniform flow is an ideal flow because uniform flow does not exist. Uniform flow does not exist, but we do assume the uniform flow as an ideal flow. We do assume for the analysis purpose, because when you take the depths are going to be constant, then obviously it is going to be idealized flow. Do you think everywhere in practical, do you think everywhere the depth of flow is going to be constant? Think about that. Can you get the depth of flow constant? No. This is based upon the assumptions that the flow is going to be a constant velocity or zero acceleration. I hope you remember the acceleration means what is the meaning of zero acceleration? Constant velocity, right? Because acceleration means rate of change of velocity. What is acceleration? dv by dt, na acceleration. Yes or no? So if I say constant velocity, then what is the change in velocity? Zero. Then acceleration is also going to be zero. Okay. So now point number 1. Where do you see the uniform flow? It can be seen in the prismatic channels with a constant velocity of flow. With a constant velocity of flow. Keep that in your mind. That's going to be with the constant velocity of the flow. Okay. Now, let's see. Coming to the non-uniform flow. What is going to be happen in the case of the non-uniform flow? I hope you understood what is the meaning of steady flow. Steady flow means the discharge remains same along the channel at a particular time, at a particular section. Wherever the time you take, the flow parameters should be constant. Okay. Now, let's take the same section. Now, think and say. Now what I'm going to do is, let me keep an obstruction over here. Let me keep an obstruction. Now what is going to be happen? It is an obstruction. Now what is going to be happen? Come on, think and say. So if I provide an obstruction, my dear students, now see in the earlier case, in this case, I told you at a downstream side, there is no obstruction. Is there any obstruction over here? No. The flow is going to be uniform. Okay. Now, when I provide obstruction, what is going to be happen? Have a look clearly. You see, at first the flow is going to be passes like a uniform. You see, up to this point, everywhere the depth is going to be same. Yes or no? Up to this point, everywhere the depth is going to be same. See, still it not reached the obstruction. Up to this point, everywhere the flow is going to be same. Okay. Now, what is going to be happen? Once it reaches to this point, so once it gets the obstruction, you see, you keep your hand, there is an obstruction. The flow is coming uniform. Now, up to this point, it is going to be uniform, my dear. Now, once the flow hits the obstruction, do you think the flow is going to be same? Think and say. Once the water gets obstructed, what happens? Once the water gets obstructed, see, when the flow is going to be happen, you know that when there is a flow, there must be some energy. Yes or no? And that energy is nothing but combination of kinetic energy and potential energy. Yes or no? When the flow is going to be happen, the flow moves with some velocity, and that gives kinetic energy. And the flow has some depth that gives the potential energy. Keep that in your mind now. Now what I am representing you here is, you see, this is an obstruction, the flow is happening, and if that flow hits the obstruction, immediately the water level will rise or not? Immediately the water level will rise. Sir, what is happening over here is, you see, when the flow hits the obstruction, then the velocity of flow will decrease. The velocity of flow will decrease. Kinetic energy will decrease. And that kinetic energy will convert to potential energy. Repeating the point again, when there is an obstruction, if the flow gets obstructed, the kinetic energy will decrease and it will convert into potential energy. What is meant by potential energy, my dear? The depth of flow or not? Potential energy means the depth of flow. So once the water level hits, then the water level is not going to be same. The water level is going to be rises. Now you see, if it hits over here, do you think the water level is going to be same or the water level is going to be rises? The water level is going to be rises. So now comes and hits, water level rises, and once this water level rises, this disturbance will travel towards whom? Upstream side. The disturbance will be traveling towards the upstream side. So due to this obstruction, the kinetic energy is going to be converted to potential energy. Means velocity head will decrease and potential head is going to be increase. Velocity head will decrease and potential head will decrease. Velocity decreases and water level is going to be rises. Once the water level rises, this disturbance will travel towards the upstream now, and this is going to be the water level. Now this is going to be the water level. So come on, now you tell me, is it a uniform flow here? So my dear student, what is the depth of flow here? The depth of flow here is y1 and the depth of flow here is going to be y2. In this case, y1 is equals to y2. But in this case, y1 is not is equals to y2, which means whatever the variation of depth with respect to space is not is equals to 0. Then we are going to call it as a non-uniform flow. flow. Sir, when does this is going to be happen, sir? Look. Some people, I already told you in the previous classes also, I know when to say, what to say, okay? Sir, most economical sections, sir, hydraulic jump. Why do you require that? Do you require that? Tell me. Do you require that? I always use this example. When you go to the movie theater, are you going to think about what is the climax, what is the climax, what is the climax? No, right? You always enjoy the movie, right? You always go with the destination. So you always go with the journey, not the destination, right? Be patient, yeah. Keep some patience with you. I'll discuss that. So don't worry, I won't leave you without discussing about the hydraulic jump or most economical sections or whatever it is. Whatever it is there for the gate examination and for ES examination regarding to open channel flow, I'll discuss about that. And I know when to say and what to say. So brace up yourself. If you know something, just undo it. So before coming to the class, I mean, everybody knows some amount of the information. I don't have any problem with it. Okay. So, but if you want to learn something, you must have to unlearn what you have known so far. You try to observe over here. I'm trying to depicting with the practical examples, and I'll give you the video sources later. So if you understand this, then only you can feel the beauty of this topic. Else, it's just like a water flow. What is steady, unsteady? I don't want you to people to mug up the definitions. I want you to people to understand what is actually happening. If there is no obstruction, I am telling you the water is having a same flow. But when I kept the obstruction, what happened? Once the water gets fixed the obstruction, then the energy levels are going to be changing and the water level is going to be disturbed, right? When the water level is going to be disturbed and the entire upstream water surface is going to be disturbed. So here the depths are not going to be seen. Yes or no? So this is going to be the unsteady flow. Now, so you go with the non-uniform flow. When do you say the non-uniform flow? Whenever the dou y by dou s is not is equals to 0, then we can say the non-uniform flow. Okay. Now, coming to this non-uniform flow again. So, where do you see the non-uniform flow, sir? It's not going to be, see, it can be seen in prismatic channels with a variable velocity, or it can be seen in non-prismatic channels also. So non-uniform flow can be seen. Non-uniform flow can be seen. Keep that in your mind. If there is no prismatic channel, what does it mean by no prismatic channel? Non-prismatic channel. What is the meaning of non-prismatic channel? Size, shape, slope changes. If all those changes, the depth of flow is also going to be changes. The depth of flow is also going to be changes. If the flow velocity is not going to be constant, then also you can see the non-uniform flow. So, non-prismatic channels are and prismatic channels with variable velocity. See, this is going to be constant velocity and this is going to be the variable velocity. So now, my dear, yeah, I will discuss something more regarding to the non-uniform flow. Study non-uniform flow. Okay. Study non-uniform flow. What is the meaning of a study non-uniform flow? You operate the gate only once, and once you allow the flow along the length, the flow parameter, the depth is changing. Okay, the depth is going to be changing. So, sir, can you provide us some practical examples? And what is the meaning of this one, sir? Sir, can I call this non-uniform flow as a variable flow? Yes, variable flow means depth is varying. And the depth may varies, and the depth may vary gradually, or the depth may vary suddenly. So for that, what I do is, I am going to take a perfect example over here. So you please try to understand that. Okay. Let me take this is a channel bed. I'm providing a very less inclination. Very small inclination providing over here. And this is a channel bed. Let's take a weir or a barrage. Okay, so this is a ogee shaped weir. This is a weir. Weir is a hydraulic structure, or we can say it as a diversion headwork, which allows the water to go from the upstream to the downstream. And whatever the top of this weir, it will be having a crust gate. So whatever this is nothing but the crust gate, please. Okay, so now let's see. This is a weir far away from the obstruction. Far away from the obstruction. Now let's see, the water is going to be flowing up. Yeah. So my dear, observe please. So far away from the obstruction. The water is flowing with some level. What is this level, please? Uniform flow. Far away from the obstruction, the flow is going to be uniform. Now, up to this point, then the flow meets like a uniform. But once it is going to be touches the weir, what is going to be happen? Once it is going to be touches the weir, what is going to be happen? Then immediately you see, I'm giving you the example. This example, see, this is the flow of water or not, and this is the weir. Once this water is going to be hits this weir, so what energy is going to be converted to what energy? Kinetic energy is going to be converted to potential energy. Okay, and this water is going to be, see, whatever this is nothing but the control gate or not. This is a crust gate, my dear. What we call it as a crust gate. Crust gate. So now, due to the obstruction, the water level is going to be rises something like this. Yes. So once the water level is going to be rises, you tell me, do you think the obstruction is going to be, the change is going to be happen over here, or it will travel towards the upstream also? As long as I don't open the gate now, the water level is going to be moves towards the upstream. And now this is going to be the water level that I can see. See, if there is no obstruction, the flow should be like a dotted line. But due to obstruction, kinetic energy is going to be converted to potential energy, and the water level is going to be changes, and it travels, and finally meets whom? Uniform flow. So now I can remove this. And how does the flow is going to be looks like over here? The flow is going to be looks like, slowly the water level is going to be rises, and rises. Okay, up to this point. Now I will divide a point over here. Whatever this is nothing but here as a uniform flow. Okay, up to this point it is going to be uniform flow. And from here onwards, the water level is going to be changes. See, for this example, the water level is going to be rising. Now, is it in an upstream side or a downstream side? Upstream side. This is upstream points. U by S means upstream side. Now coming to the downstream side. Now you open the gate. Now you open the gate. If I open the crust gate, what is going to be happen? Think. If I open the crust gate, what is going to be happen? So this water will pass over the weir. This water will pass over the weir. And this water will pass over the weir like this. When the water is going to be passes over the weir, let's assume the weir is going to be frictionless. Let's assume the weir is going to be frictionless. What is the meaning of frictionless? No head loss. So that no change in the energy. Now, once the water is going to be hits the ground like this. Now, with your common sense, can you please tell me, once the water is going to be hits over the surface, you see in the case of the upstream side, you see in the case of the upstream side, which energy is going to be converted to which energy? Come on, tell me now. Tell me, think and say. Once the flow is going to be gets obstructed over here, which energy is going to be converted to which energy? Kinetic energy converts to potential energy. My dear, here kinetic energy means representing with velocity. Potential energy means representing with the depth of flow. Okay. So on the upstream side of an obstruction, velocity will decrease and the depth of flow is also going to be increases. Yes. Now, when I open the gate, the water will fall over here. Now, once the water is falling from certain height, the velocity of flow would be more or potential energy is going to be more. Kinetic energy is going to be more. So now, my dear students, once you allow the gate, the flow will fall and now on the downstream side, the kinetic energy of the flow is going to be more. The kinetic energy means the velocity of flow is going to be more. Potential energy is going to be less. So simple words, on upstream side, kinetic energy converts to potential energy. And on the downstream side, potential energy is going to be converted to kinetic energy. And then, do you see the flow is going to be normal like this? No. Once you observe, if you pour a bottle of water, then once it hits the ground, some portion of the water will get reflected back. And now, it is going to be create a, once it hits over here, repeating the point again, from this point to this point, as from this point to this point only, as that weir is a frictionless, no loss of energy. But once it hits the ground level, once it hits the ground level, do you think the energy is going to be seen? No. Once the water hits the ground, the energy will be dissipated, yes or no? And now, as the water is going to be rising against the gravity, what is the open channel flow? Open channel flow is a gravitational flow or against the gravity? Gravitational flow. Once the water is going to be rise against the gravity, now it is going to be rises up and falls down. Rises up and falls down. And this is known as a hydraulic jump. This is known as hydraulic jump. Sir, why the hydraulic jump is going to be formed? Just give me a few moments of time after this. Then we can discuss about how the hydraulic jump is also going to be formed. Listen to that. Okay. Now, so once I open the gate, the water level will fall and then it is going to be moved and then it is going to be rises and rises. See, do you think, does this water level, the downstream water level will rise up, will rise to the same point as the upstream water level? No. Now, you see this water level is going to be rises and after some time it reaches to the uniform because the disturbance has been done or not. It is going to be uniform, uniform, uniform. Now, again, this is going to be uniform flow. Sir, why it is rising like this, sir? Why the hydraulic jump is going to be formed? I'll give you the reason later. But as of now, whenever you open the gates, you just imagine there are a lot of videos. You can go through that videos in YouTube. When you open a gates of a dam, what happens on the downstream side? Water level will fall and there is a hydraulic jump is going to be takes place. And then after some time, the water level reaches the normal level known as uniform level, uniform flow. So in this entire, what is happening? From this point to this point, the water level is rising, falling, and rising. Can I say it as a non-uniform flow? Yes or no? Can I say it as a non-uniform flow? And is it a steady non-uniform flow or unsteady non-uniform flow? This is a steady non-uniform flow. So in the case of the steady non-uniform flow, steady state non-uniform flow. Now again, I am going to divide it into two parts. One is GVF. What is meant by GVF? Gradually varied flow. What is meant by GVF? Gradually varied flow. Gradually varied flow. In simple terms, GVF. And non-uniform flow, it also can as a rapidly varied flow. This is going to be RVF. Gradually varied flow and rapidly varied flow. Sir, what is the meaning of this gradually varied flow and rapidly varied flow, sir? Both are varied flows, but if the variation occurs over a long span, if the variation occurs over a long span or longer stretch, then you are going to call it as a gradually varied flow. So when there is a non-uniform flow, if the variation happens over a longer span with a very small curvature, what is meant by curvature? The slope. You see here, if I draw a tangent, the slope of this curve is going to be very less. Yes or no? For this, if I draw a tangent, the slope is going to be very, very less. But you see here the slope is going to be very large, because if I draw a tangent, this is the tangent. Am I correct or not? So now, my dear, when do you say uniform? When do you say GVF or when do you say RVF? If the variation is going to be happen over a longer span, or if the variation is going to be very, 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 very less, then we call it as a gradually varied flow. Can I say from here to here, whatever, this is nothing but gradually varied flow. This is going to be the gradually varied flow. Yes or no? Because here the variation is going to be happening over a longer span, and this is going to be a smooth curve. And when you see the curve also, that's going to be a smooth curve. And the curvature, what is meant by curvature? Slope is also less. In simple words, if the variation happens over a longer span, you call it as a gradually varied flow. But now you see this portion, within a short span, the water level has been fallen down. And within a short span, the water level has been rising down. Yes or no? Then you are going to call this one as a rapidly varied flow. Rapidly varied flow. And what is the example of the rapidly varied flow? The example of the rapidly varied flow is going to be hydraulic jump. So what is the condition required for the hydraulic jump? Wait for the moment and I'm going to disclose that for you. So now, come to this point over here. Look, gradually varied flow and rapidly varied flow. So where do you see the example? Whatever, this is nothing but backwater curve. We call it as a backwater curve. So the example for the GVF is going to be backwater curve, and for RVF it is going to be hydraulic jump. I hope you understood here. See, this is one of the example, and likewise you can create lots and lots of example. Not only this one, but for RVF, for hydraulic jump is the best example. For RVF, the hydraulic jump is the best example. For GVF, you can take some more examples. So I hope you understood. This is a practical approach. What is happening on the upstream side of a dam? This is upstream side, and this is going to be the downstream side of a dam. So when does the flow starts? Like uniform, and due to obstruction, water level rises. It is a GVF, and once you open the gate, so whatever the fall, so here sudden change. If the variation happens over a small span or short span, then you can call it as a rapidly varied flow. So I hope you can understand. So first one, general classification, uniform flow, and in the case of the steady non-uniform flow, I have been explained about the gradually varied flow and rapidly varied flow. That's going to be the hydraulic jump. It's already 8:53. We'll have a small break and then we'll start our resume. We'll resume our session at 9:10. Please have a break. Please have a break and I'll start the session again at 9:10. Okay, let's resume our session. Hope people are there. Okay, I hope you understood what is the meaning of this steady non-uniform flow and steady uniform flow. Now let's go back to the unsteady states. So coming to the unsteady state, what is the meaning of unsteady state? What is the meaning of unsteady state? Now, you see, in the case of the unsteady state, what is the meaning of unsteady flow? Flow parameters will change with respect to time. Flow parameters will change with respect to time. That's going to be the unsteady flow. So now you see, in the case of unsteady flow, let's say same example. In same example, for a small change I am going to introduce. Okay. So now what is the meaning of unsteady flow? Unsteady flow means a flow parameters changes with respect to time. Okay. So now let's say initially let's take this is position number 1. Initially the water level is going to be this one. With respect. So now from here, this is the water level. Okay. Now if I suddenly lift the gate from 1 to 2, if I suddenly lift the gate from 1 to 2, what is going to be happen? The water level is going to be rises to here or not? Yes or no? So if we suddenly operate the gates, now when you suddenly lift the gate, the water level will rises and it is no more this position now. Yes or no? So from 1 to 2, what is going to be happen over here? This portion has been lifted from 1 to 2 due to sudden rise in the water level. Then this water level gets fluctuate and forms like this. This water level gets fluctuate and forms like this. Okay. Such a flow is known as an unsteady flow. And in the case of the unsteady flow, my dear, uniform flow will never be possible. In the case of the unsteady flow, means by sudden operation of the gates, uniform flow will never be possible. Because what is the meaning of uniform flow? Think and say. Along the length, the depth should be same. Okay. Now listen. Let's say whatever the hand movement I'm showing you here. Let's say over a distance of, for example, over a distance of 1 kilometer. Let's say this is the initial uniform flow. Now you suddenly raise the gate. When you suddenly raise the gate, the water level will rise or not? Now the question is, do you think over a kilometer length the water level will rise from 1 to 2? Do you think what is the meaning of uniform flow? After you raise the gate also, the depth should be constant. Yes or no? The depth should be constant. Is it going to be possible? This is A. Before lifting of the gate, flow is uniform. And this is B. After lifting of the gate, do you think everywhere over a 1 kilometer length, do you think everywhere the water level will rise by same amount? No, it is not at all going to be happen. Keep that in your mind. uniform flow will not possible under unsteady case. If I say uniform flow, that is a steady uniform flow only, and unsteady uniform flow will not be possible. So I can write uniform flow will not possible under unsteady state conditions. Unsteady state condition. Okay. Now coming to the non-uniform flow. So go back over here. This is not possible. Now coming to the non-uniform flow. In the case of unsteady flow, now in non-uniform flow, again, there is a GVF, there is a RVF. Sir, can you tell me one of the best example in the case of unsteady flow, sir? Apart from this sluice gate, you just imagine drop a stone into a flow of water. What do you observe? Let's take a pond. So you can see some still water. In childhood, we used to drop stones and observe what is happening over there, right? So now, if you drop a pebble or a stone into a pond, what you can observe? When you drop the stone, immediately it will create ripples or disturbances, or not? Yes. So wherever you drop the stone, think and say, wherever you drop the stone, immediately make sure that the water level will rise. Yes or no? What is the meaning of water level rises? So at this particular section, water level rises or falls means unsteady state. So at a particular section, if depth varies, that is unsteady. Okay. Now, once you drop the stone, do you think the waves are going to be produced there itself, or they are going to be produced along the length also? Do you think the ripples are going to be traveled along, or they are going to be formed there itself? When you drop the stone, the ripples are going to be traveled. So at that particular instant or section, water level fluctuate, and they are going to be fluctuate over the length. So my dear, observe here clearly, unsteady flow, and this variation is happening over the length. Unsteady non-uniform flow, because along the length also water level is going to be fluctuate. So wherever you see the wave pattern, right? Whenever you see the wave pattern in the flow, that is unsteady flow. And if that wave pattern is going to be gradual, then we are going to call it as a gradually varied flow. Example, flood waves in rivers. We call it as a unsteady non-uniform gradually varied flow. Unsteady non-uniform gradually varied flow. And coming to the tidal waves, I hope you have seen this one. I don't need to say much more also. You know how the tides are going to be generated, right? So in oceans, how the tides are going to be generated. So do you think the tides are going to be uniform flow or steady flow? No, right? The tides will come and go. And when it is coming, keep that in your mind. The tide is going to be rises and falls or not? Rises and falls unsteady. Rises or falls unsteady. And does the tide is going to be formed at a particular point, or it will travel along the length to the shore? The tides are going to be traveled to the shore or not? When the tide is going to be rises and falls, that is going to be unsteady in nature, and that unsteady nature will travel along the length. If the variation occurs along the length, that's going to be non-uniform flow. So unsteady, non-uniform, rapidly varied flow can be seen in the case of tidal waves or sudden operation of gates. We call it as surge. We call it as surge. So what is meant by surge, that we will be discussing later. So my dear students, I want to give one more conclusion over here. This is unsteady flow. Unsteady flow is a highly unsteady, as the name itself says that it is a highly unsteady. So as we do the analysis, we always go with the steady, right? So most of the open channel flows are steady flows. In the analysis, 95% of the discussion we are going to deal with the, we are going to deal with the steady flows only. And there comes, I am going to tell you what we are going to discuss in the later chapters is we discuss about the uniform flow. We discussed about the we are going to discuss about one chapter as uniform flow, and we are going to discuss about the non-uniform flow. And in the non-uniform flow, one chapter is going to be gradually varied flow, and one chapter is going to be a rapidly varied flow. And finally, we are going to deal with the unsteady flow. It's very, very small part, and it is not important for the GATE and IES examination also, but we have to discuss. So there was once one or two questions has been appeared in the previous GATE questions, but my dear, for any competitive examination, they will focus more on the steady flow rather than the unsteady flow. Even for the analysis also, we focus on the steady flows, not on the unsteady flows. I hope you understood what is the meaning of a steady flow, unsteady flow. In the unsteady flow, after certain level, it won't be uniform. Yes, it won't be uniform, Nana, because unsteady itself means no uniform. In the case of unsteady flow, uniform flow will never possible. Have a look. I hope you're able to see this video. So see, you can go through this video. You can go through this video, us.fhwa. So this is going to be the open channel flow concept. He was very well explained. I hope you people are seeing this. Maruti Savant, can we say waterfall also forms hydraulic jump? No, it's not going to be that way. That's why, just wait. I did not give you that reason. Just wait for that. Tidal meaning is tides, Rababa, tides. Have you never seen a tides in an ocean? Waves. I did not say practically steady is not possible. I said practically uniform flow is not possible, not steady. Keep that point. I said you practically uniform flow is not going to be possible. Wherever you see, most of the cases, what you see is a steady, non-uniform flow. Okay. So you please go through this one, this video, open channel flow concepts. There, this professor has explained the classification of flows by taking some practical example in the laboratory. You please go through that video so that you can understand much more better. Whatever the explanation I have given, that will be taken care over here. And see. You can observe, I hope. Please have a look about the video, everybody. Yes. So now everybody, if you look, the flow is falling from certain height, right? The flow is falling from the certain height. When the flow is falling from the certain height, see, does this just exactly looks like a weir or not? Okay. So when the flow is going to be falling from the certain height, now whatever, this is going to be the upstream side and here it is going to be the downstream side. When the water falls, you can see some undulations are going to be present over here. The water level is going to be rises in a small portion, right? This is known as a hydraulic jump. Whatever is going to be the hydraulic jump. So yes, come on. You can see the formation of the jump over here, small jump. This is a very small jump. This is a flow of water. Now I'll show you clearly what is the hydraulic jump over here. Yes. You please observe this portion. You please observe this portion. See, whatever this is known as a hydraulic jump. This portion, see this portion, whenever this flow is going to be meets now, you observe now. Yeah. What is happening at this position? You see, what is happening at this position? Some flow is coming and it is meeting some other flow, and at this point the flow is going to be moved in a reverse direction or not? The flow is going to be moved in a reverse direction. So why it is possible, sir? Why it is happening like this? And there is the reason behind that is you have to classify the flow. See, you can observe over here, this is one portion of the flow. This is one portion of the flow while it is happening. So this is known as a supercritical flow. And whenever the supercritical flow is going to be meets, whenever the supercritical flow is going to be meets the subcritical flow, whatever is going to be the subcritical flow, then you are going to see the hydraulic jump. You observe, please, when you open the gate. Yeah, I hope you can see this now. You please have a look what is happening over here. This is opening of a gate, and on the downstream side, whatever this is yes, whatever this is nothing but a hydraulic jump on the downstream side. This is a sluice gate in this experiment. Yes, have a look. So you can see a reverse of flow is going to be happen or not. This is on the downstream side, and then some reverse flow is going to be happen. There is a hydraulic jump. So why this hydraulic jump is going to be happen? You see now, this is a very perfect example. You can understand. Here the level of water is very less. Here the level of water is going to be very less, and here the level of water is going to be more. And now whatever the figure I have given you earlier, you see the flow is going to be passing, and then it comes, and you can see some rollers are going to be formed inside, and then it is going to be looks like this. But what is the initial depth over here? This is the initial depth, and this is the final depth. Yes or no? Does the initial depth and final depth both are same? No. Whatever this is known as a hydraulic jump. So this was created in the laboratory. Now I hope you can understand much more better. Yes. Yes, you observe over here. You can see whatever in the portion, you can observe the flow is going to be passing in a reverse of flow. It moves forward and backward, and it is creating some disturbance over here. And due to that disturbances, the energy is going to be dissipate. The energy is going to be dissipate because energy is going to be lost. That is the reason why the water will not rise to the same height. And it is going to be exactly similar to here. Please observe. Now, let me give you the reason behind this. So there are a lot of videos like this. You can go through that videos and I can send you those videos. You can go through that videos. Now, in order to explain this one, I'll go for the discussion first. Yeah. Okay. Now, my dear, now comes to the discussion, please. Here, we are going to discuss about the effect of gravity and viscosity on flow behavior. So what is the effect of the gravity and viscosity on the flow behavior? So as I said you, the note point is almost all OCF deals with steady flow. So now, what is the effect of the gravity and viscosity on the flow behavior? I told you in the starting classes or earlier classes, I have given you some forces, right? So you please go through that forces once again. What are those forces? Yeah. So these are the forces acting on the liquid medium. And I told you the compressible force neglected, surface force neglected, pressure force neglected, and remaining forces are gravity and viscous forces. But in open channel flow, gravity force is predominant than the viscous force. And whenever there is a gravity force, which number I have to use? Froude's number. So now I am going to use that classification based on Froude number. Number 1, Froude's number. And you know that Froude's number Fr is equals to V by root of GL. V by root of GL. Now I am going to give what is this L, sir? L is nothing but characteristics dimension. In open channel flow, the L is going to be replaced with D. What is D? It is not a diameter, by dear. It is a hydraulic depth. It is a hydraulic depth. So in open channel flow, for Froude number, it is going to be D. So now I can rewrite this one as V by root GD. V by root GD. So I hope you understood the definition. So Froude number, and now the L is nothing but D. Why we take D, sir? Sir, D is nothing but average depth of flow, sir. When we analyze, sir, are we taking maximum depth or average depth? Average depth. So that average depth is nothing but hydraulic depth. And you know that in the case of rectangle, D is equals to Y. And in the case of the triangle, D is equals to Y by 2. In the case of a trapezoidal, as half of regular hexagon, D is equals to 3 by 4y. If you have any doubt, you can go back and you can look. Now, what I want to say over here is, whenever there is a flow, see, this is a flow, right? The flow behavior is going to be affected by the gravity and viscosity. This flow behavior is going to be affected by the gravity and viscosity. Why the hydraulic jump is going to be formed? That is, there is a reason behind that. And what is that reason? Now we'll see. That is based upon the Froude's number. And this Froude number depends upon velocity of the flow and d. And d depends upon whom? Shape. So for as the shape of the channel changes, Froude number changes. If I send same discharge at the same velocity, same discharge at the same velocity in rectangle and triangle, don't think the Froude number is same, because in rectangle d is y, in triangle d is equals to y by 2. Okay. So now from this Froude number, based upon this, how we are going to classify the flow and depth. Classification of flow based on Froude number. Based on Froude number. So A, critical flow. Critical flow. So when do you say critical flow, sir? Sir, in the case of Reynolds number, you are going to say laminar or turbulent or transition. But in the case of the Froude's number, you don't say transition or turbulent. We say critical, subcritical, supercritical. So when do you say it is going to be critical, sir? Whenever the Froude number is equals to 1, then we say the flow is a critical flow. And we say the velocity is going to be critical velocity. Whatever the velocity is going to be, critical velocity. And we say whatever the depth is going to be, critical depth. Critical depth. So whenever the flow is going to be critical flow, we call it as a critical velocity and we call it as a critical depth. Now, let's see. You know that Froude number Fr is nothing but V by root of G into D. Yes or no? Yes. Now, in this equation, whenever I write Fr is equals to 1, V becomes Vc, D becomes DC, and Vc by root of G into DC is equals to 1. Now, can I write this one as Vc is equals to root of G into DC? Now, can I write this one as Vc squared by G is equals to DC? What is meant by DC? Hydraulic depth at critical state. And you know that in turn the hydraulic depth depends upon whom? Depth of flow, right? In turn the hydraulic depth depends upon whom? Depth of flow only. Is there any other parameter in hydraulic depth? No, that's average depth, right? Whether it's 1 by 2, R2, R3, or whatever it may be, it is a direct function of y. That's it. So now, can I write this V as a Q by A? Yes. Now I can write this one as a Q square by A square into G. And what is a D? What is meant by D? D is nothing but a hydraulic depth, and hydraulic depth can be written as A by T. Can I write like this? Yes. Now you take A square to the other side, then Q square by G is equals to A cube by T. My dear, this is the equation at which we are going to state the flow is going to be critical flow. If you want to make sure the flow is a critical flow, so the condition required, the must and should condition required for the critical flow is going to be the Q square by G is equals to A cube by T. Keep that in your mind. It is not going to be stop you here. It is going to become along with you throughout the chapters. And this is very, 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 very important. So this is known as critical flow condition. What do we call? This is a critical flow condition. When do you say critical flow? When you send a discharge, of Q as Q square by G is equals to A cube by T, then the critical flow condition is going to be attained. Then the Froude number is equals to 1. I hope you understood what is the meaning of critical flow. So when does the critical flow is going to be happen? And Froude number is equals to 1. Sir, why you are saying critical, critical, critical? What is the real meaning behind it? Just for that, we have to look over one topic known as specific energy. There you can understand much more better. But as of now, if I say critical flow, when does critical flow exist? Froude number is equals to 1. And what is the velocity? Critical velocity. And what is the condition required for that? Q squared by G is equals to A cube by T. Now, second one. Subcritical or tranquil flow. Subcritical or tranquil flow. See, we call it as subcritical flow, or in some textbooks, they try to misguide you. So by giving a name known as a tranquil flow. Sir, when do you say the subcritical flow, sir? Whenever the Froude number is less than 1, we call it as a subcritical flow. Whenever the Froude number is less than 1, we call it as, so derivation is important for the examination, because without the derivation, you cannot understand the remaining topics, my dear. So derivation is not important, but understanding of the concept is important. Okay, wherever there is necessity, there only I will give the derivations. I don't give any unnecessary derivations for you, so don't worry about that. This is not derivation, just an explanation. So when do you say the flow is going to be subcritical, sir? Whenever the Froude number is less than 1, then we say the flow is going to be subcritical, my dear. Now, listen to this point here once again. When Froude number is equals to 1, what is velocity? When Froude number is equals to 1, what is velocity? Critical velocity. If I want to make sure Froude number less than 1, then the numerator should be less or not? Yes or no? Then the numerator should be less, which means velocity of flow is less than critical velocity. When the velocity is going to be critical velocity, Froude number is 1. If the velocity is less than critical velocity, then the Froude number is less than 1. Okay? Yes. Now, let's take for rectangle or any other channel. What is a D? D is a function of y. Yes or no? And Froude number is inversely proportional to D. Yes or no? Froude number is inversely proportional to D, and D is directly proportional to y. So now, when Froude number is equals to 1, D becomes DC, y becomes YC. And if I want to make sure Froude number is less than 1, means if you want to make sure the total value less than 1, the denominator should be more or not? Yes. Then y should be greater than YC. Whenever the flow velocity is less than the critical velocity and the flow depth is more than the critical depth. What is y? Flow depth. What is YC? Critical depth. Then you are going to state the type of flow as subcritical flow. The type of flow as subcritical flow. So in other words, I can write this one as flow with larger depth and lesser velocity is known as a subcritical flow. Flow with a larger depth and lesser velocity is known as a subcritical flow. I hope you understood. If you want to make sure FR less than 1, numerator should be less, denominator should be more. Numerator velocity less than VC, denominator YC, denominator Y is greater than YC. Then we call it as a subcritical flow. Now, third one. Supercritical or shooting or torrential flow. All names are same. Supercritical or shooting or torrential flow. And what is remaining? When Froude number is greater than 1, then we are going to call it as a supercritical flow. When Froude number is greater than 1, then we are going to call it as a supercritical flow. Okay. Now, when the Froude number is greater than 1, if V becomes VC1, if V greater than VC, then Froude number is greater than 1. And y is going to be less than yc. So if these conditions are going to be satisfied, then we are going to call it as a supercritical flow. Now can I write this one as flow with lesser depth and large velocity. So wherever you see, my dear, now I want to conclude as after all this discussion, wherever you see, if the flow is passing with a less velocity, means if the velocity of the flow is less and the depth is going to be more. The flow with a larger depth and smaller velocity is known as a subcritical flow. The flow with a larger depth and lesser velocity is known as subcritical flow. And the flow with a smaller depth and larger velocity is known as a supercritical flow. The flow with a smaller depth and larger velocity is known as a supercritical flow. Okay, I hope you understood this, right? Now let's get back to the now coming over here. Can you tell me what is the nature of flow over here? Can you tell me what is the nature of flow over here? On the just upstream side of an obstruction, what's the type of flow? See here, you know that due to obstruction, kinetic energy is going to be decreases and potential energy is going to be increases. Yes or no? Which means obviously just on the upstream side of an obstruction, the flow velocity is less, depth is more. Wherever there is a flow, see this is a GVF or RVF, okay fine, but the behavior of the flow is like sub or supercritical. Whatever the flow over here, the velocity is less and depth is more. Flow with larger depth and lesser velocity. Flow with larger depth and lesser velocity is known as subcritical. What do we call subcritical? So I can say this is going to be subcritical over here. Here it is going to be subcritical. Yes? Now, listen. Water is going to be falls from here to here. Yes or no? When the water is going to be falls from here to here, now you tell me here at this point, you can observe the flow is going to be having a lesser depth or larger depth, very small depth. And moreover that, when the flow falls from this height, the potential energy is going to be converts to whom? Kinetic energy. See, energy is not going to be dissipated over here. Energy transfers from one state to other state here. So when the water level falls from the top of here to the bottom, potential energy converts to kinetic energy, which means velocity is more, depth is less. Flow with smaller depth and larger velocity, here it is going to be super critical. Now again, as the water level is going to be rises and rises, again it reaches to the final position or not. And here the depth is going to be large and velocity is going to be less. This is again here subcritical. I hope you understood the definitions. So whenever the flow is going to be having a larger depth with a lesser velocity, we call it as subcritical flow. Flow with a smaller depth and a larger velocity, we call it as a supercritical flow. Now I hope you may understand when does the hydraulic jump is going to be happen. Think and say please. When does hydraulic jump is going to be happen? Whenever the supercritical flow meets the subcritical flow. Whenever the supercritical flow meets the subcritical flow, then only hydraulic jump is going to be happen. Now, what is the condition for hydraulic jump? Whenever a supercritical flow meets the subcritical flow, then the hydraulic jump is going to be occur. This is what I want to conclude based upon the Froude number. I hope you understood with these examples. Yes. So the note point here is hydraulic jump occurs when supercritical flow meets subcritical flow. Sir, how come you say whether it is supercritical or subcritical, sir? You find out the Froude number, sir. If the Froude number is less than 1, subcritical. If the Froude number is more than 1, supercritical. Sir, how to find out the Froude number, sir? Froude number Fr is nothing but V by root GD. You find out the velocity of flow. If you know the velocity of flow and hydraulic depth of the channel section, then you can find out the Froude number. Once you know the Froude number, Fr less than 1, subcritical. Fr greater than 1, supercritical. I hope you understood this. So this is the effect of gravity. This is the effect of the gravity. Now, Reynolds number. Effect of viscosity. Effect of viscosity. So in the case of the Reynolds number Re is nothing but rho VL by mu. Generally, where L is the again here characteristic length. L is again in characteristic length. Okay. So now in pipes, L is nothing but dia of pipe. L is equals to D. So in the case of the pipes, Re is nothing but rho Vd by mu. Rho Vd by mu. But my dear, in open channel flow, L is equals to R. In open channel flow, L is equals to R. So now what is Re? Rho Vr by mu. Rho Vr by mu. See, in the case of the pipe flow, we have to take L as a dia of the pipe. And in the case of the open channel flow, L is equals to R. So some of the people were asking me, so what is the significance of hydraulic radius and hydraulic depth? Sir, hydraulic depth is used in Froude number to classify the flow. Froude number. In the case of the Froude number, L is equals to D. And in the case of the Reynolds number, L is equals to R. Sir, now you know that in pipes, just go back. When flow runs, this is the pipe flow or not. What is R value? What is R value? D by 4. So I told you whether the flow runs full or half. What is the meaning of when flow runs full? The meaning of flow runs full is pipes. In the case of the pipes, R is equals to D by 4. Yes or no? In the case of the pipes, R is equals to D by 4. Now can I substitute D as 4 times of R? Then I can rewrite this in terms of, see, D can be written as a 4 times of R. So now rho V into 4R by mu. You can see the Reynolds number in pipes is different. The Reynolds number in open channel flow is different. Okay. And based upon this, you know, when do you say laminar flow and turbulent flow? In the case of the pipes, when Re is less than 2000, we call it as laminar flow. Okay, fine. But you come to the open channel flow. See here, and R, I can write this one as 4 times of rho VR by mu R naught. Yes or no? So whatever the Reynolds number in pipe, is equals to 4 times of Reynolds number in the open channel flow R naught. Yes or no? Then what is the Reynolds number in the open channel flow? 1/4 of the Reynolds number in the pipe flow for laminar flow. 1/4. What is 1/4 of 2000? Less than 500. Just multiply with 4, right? 500 into 4. If you multiply with 4, 500 into 4, then RE less than 2000, RE less than 500. Then you can call it as a laminar flow. Laminar flow. And in the case of the remaining, see, this is valid up to laminar flow. Now, (2000 to 4000). Transitional flow, yes, and more than 4000 turbulent flow. Now, just simply multiply with 4 for this 500, multiply with 4 for 500. So 500 less than RE less than, multiply with 4, 2000. This is going to be the transitional flow, and the RE greater than 2000, here it is going to be turbulent flow. So see, that's the reason why I am writing for laminar, and for in the case of the laminar flow, I am representing the difference. Okay. If you see, in the case of the laminar flow, I am showing the exact difference, 4 times difference. But for the transition and turbulent, don't ask me, sir, here it is 2000. Na? Then if you multiply with the 2000, so 4000, you have to take it as 1000, sir, but you are taking 2000. Don't ask me that question. Because this is valid up to laminar flow. This is valid up to laminar flow. And for the remaining things, you just multiply with 4. For 500, you multiply with 4. That's it. So, but anyways, in the case of the open channel flow, we don't discuss about the Reynolds number much. You know that. Which force is a major force here? Gravity force. So I don't discuss much regarding to the Reynolds number, but we must need to remember, when do you say laminar flow in pipes? In the case of pipes, RE less than 2000, and in the case of the open channel flow, RE less than 500. Then we can say it as a laminar flow. And in soils, right? Whenever there is a flow in soil, see phase, there RE less than 1 is known as a laminar flow. And in the case of environmental engineering, I hope you came across the sedimentation analysis. There you came across the Stokes law. In the Stokes law, again, in Stokes law, there is Reynolds number. There RE less than 1. So type of medium changes for laminar flow, Reynolds number is also going to be changes. Okay. So that's all for today. With this, we have classified flows, a general classification of the flow we have done. So by taking some examples, so these are some of the examples. So you can go through these examples later, and have given some example for the circular sections and all those things. And then we discussed about the classification or effect of gravity and viscosity on the flow behavior. And this is very, very important. From tomorrow onwards, we are going to discuss about these things only. So with this, I will conclude today's session. That's it for today. We'll see the remaining things tomorrow. It's already been 10 o'clock. We'll see remaining things tomorrow. And one more thing, we'll keep the doubt clearing session tomorrow, because you have to go through these flows. First you go through the flow, you understand the flows one by one. So at this point of time, if you ask a doubt also, your doubt is going to be half filled. So you go through the notes once again, and then, especially I'm telling you this classification of flows. You go through the notes once again, you go through the videos, whatever the video I have shown you. So that us.foh, you please go through some of the videos, and then you can understand much more better. If you still have any doubt, you can contact me tomorrow. And today I am not going to take any doubt clearing session. And tomorrow I am going to take for the total, whatever the concepts I have taken today and tomorrow, I am going to take the doubt clearing session. So you are not ready to solve some questions because in open channel flow around 30% is about basics only. First of all, you need to know the basics, then you can understand. So you cannot solve the questions now, but I'll tell you when we are going to get. Tomorrow is a holiday, no holiday, no holiday, no holiday. Especially for us, no holiday at all. August 15 is Independence Day for the India, not for us. Okay. So don't worry too much of your independence. You have a lot of time to get that independence as you are dependent now on your parents. So there is no holiday for tomorrow. Even if they say holiday, I will insist them to keep the class. Keep that in your mind. Okay. We'll see tomorrow. So I'll be attaching the PDF within 20 minutes. So you can go through the PDF and you can download it and you can see that. We'll see you tomorrow.